Welcome to my DER video on the Reverse Polish Notation, or RPN, calculator project. In this video, I will walk you through the design and functionality of the RPN calculator using an Arduino Nano, LCD screen, and custom code.
The goal of this project was to create a functional RPN calculator that takes inputs through buttons, 6, enter, 6, enter, performs calculations, multiplication, and displays the results on an LCD screen.
The main hardware components used in this project include an Arduino Nano, a 16x2 LCD display, a 4x4 button matrix, and a 10K pop pin. Each button in the matrix represents a number or operation, and the Arduino handles the input and calculation logic. Each button and resistor was hand soldered onto the PCB to ensure a strong and clean finish.
This is the RPN calculator in action. How reverse Polish notation works is it inputs the numbers first, then the operator second. Right now, the Arduino has an empty stack class. That means there's nothing in the stack, but we need to push some operands to the stack. So first we will push 6, which is now on the top of the stack, and another number, 9, is on the top of the stack. Now that we have two numbers, we can use one of the operators to perform a calculation. For example, plus 15. Now that we have 15, this means that the two previous numbers were popped off the stack, and now 15 was pushed onto the stack. Now we only have one number on the stack, so let's add another. Let's do 10. Now we have 10 on top of the stack. And if we click multiplication, 150. That is now at the top of the stack. The order of operations for addition and multiplication don't matter. It can go top of the stack, and then second from the top, or second from the top, then the top. So the code sees which one of the operands was popped first and puts it in order. So for example, if you have 10 on top and 2 at the bottom, then it will do 10 divided by 2, or 10 minus 2. The result will always be in the middle of the LCD screen. How this works is there's an if-else ladder, seeing if the result is less than 10, then the LCD set cursor function will put it on the 5th LCD point. Now, if the result is greater than 10, but less than 1,000, like we have here, it will be put onto the 4th digit, but really it is the 5th space. Now, if we multiply this by 10,000, because this number is between 10,000 and 1,000,000, it will be put onto the second place of the LCD screen. I will now explain how the resistors and button inputs are identified using thresholds, a key concept in this project. The button matrix is composed of rows and columns. Each button is located at an intersection of a specific row and column. To detect a button press, I use the concept of resistance. When a button is pressed, it connects a row and a column, creating a path for current to flow. To detect which button is pressed, I use different resistor value in each row of the matrix. The Arduino applies a voltage to the rows and then reads the voltage at the columns. If a button is pressed, it creates a change in resistance that alters the voltage at the column pin. By comparing the voltage readings to the predefined thresholds, the Arduino can identify which button was pressed. Each row has a specific resistor that helps create a unique voltage signature.
Thank you for watching my video on the theory and example of the RPN calculator project. The code for this project is linked in the description. Thank you.